Section 1.4, to identify segments, rays, parallel lines, and planes. A segment is part of a line consisting of two endpoints and all points in between those two endpoints. Here I have drawn a line, line AB, and we know this because of the symbol I have generated above AB. In line AB, I have a segment, segment AB. Notice the symbol is going to change because I have an arrow on both ends, which represents the lines. Here, I just generate a segment denoting the two lines. I can also write segment AB as segment BA. These two symbols and this drawing represent all points of A and B and all points between A and B. Points outside of A and B represent points that are part of line AB, but not segment AB. Our next slide. A ray is part of a line consisting of one endpoint and all points of the line on one side of that endpoint. Here I have a diagram of line AD. On this line are several rays. Some of them can be labeled differently but make up the same set of points, therefore they would be the same ray. Other ones would be labeled differently and would not be the same set of points, therefore would be different rays. Similar rays would look something like this. For example, ray CA and ray CB are the same rays. First, all rays must start with its endpoint. Point C is my endpoint for CA and CB. CA and CB are the same ray because they have the same endpoint and they consist of all points to the left of C, which include point A and B. Notice the symbolism for writing a ray. As we have seen before, with a line, it has two arrows on the symbol. A segment has no arrows, and a ray will have one arrow aiming to the right. Let's take a look at another set of rays. For example, ray BA and ray BC. They have the same endpoint, but BA goes to the left and BC goes to the right. Therefore, they do not set up with the same set of points. Therefore, these rays are not the same. Another ray that is similar to ray BC or is the same ray would be ray BD. Another set of rays that are not the same rays would be an example of ray BD and ray CD. First of all, they don't have the same endpoint, and we know that because the first letter in writing the symbolism would have to be the endpoint. Here, the endpoint is B. Here it is C. Therefore, we know they're not the same because they don't have the same endpoint. Secondly, because we have a set of points in ray BD that are not in CD, and that set of points would be the segment of BC. Opposite rays are two collinear rays with the same endpoint. Opposite rays always form a line. Here I have a diagram of line EH. Let's identify some opposite rays. For example, if I have a starting endpoint of F, then I have a ray FE and a ray of FG. This satisfies the definition that they both have the same endpoint. The points E, F, and G are collinear. Therefore, they would form a line, and this would be a set of opposite rays. Another set of opposite rays would be GE and GH. They satisfy the conditions for opposite rays. The endpoints G are the same, and E and H are collinear. Therefore, these are opposite rays, and these two opposite rays would form a line. Let's answer some questions based on the previous definitions. We have a diagram, and they want us to name four segments. Let's start out with segment AB, BC, CE, and CD. Name four rays. Ray AB, I cannot name ray AC or AD because that would be the same as ray AB. So ray BA, ray CD, and ray CE. Name two pairs of opposite rays. First, they have to have the same endpoint, which I will start with B, BA, and another endpoint of B would give us a ray of BC. Another pair of opposite rays would be ray CD. Has to have the starting endpoint of C, and I will call that ray CB. Are ray CA and CB the same ray? First, they do have the same endpoint of C, CA and CB. Since they consist of the same set of points and they have the same endpoint, that would make them the same ray. So the answer is yes, they are the same ray. Are ray AD and BD the same ray? I don't even have to look at the diagram above to know that they are not the same ray because they don't start with the same endpoint. Therefore, they can't be the same ray. Continuing, intersecting lines, lines that have a point in common and they are in the same plane. We've already looked at this from previous sections, and we do know that when lines intersect, they must intersect at a point. Parallel lines, two coplanar lines that do not intersect and are in the same plane. Here I have a diagram of what I will call two parallel lines. Notice these two lines do not intersect and they are in the same plane. For example, they're in the plane of the white background of the screen you're watching. Now, all we have to do is write a notation for parallel lines. Here, line AB is parallel to line CD. This is the symbol for parallel. We can also write this with the lowercase letters. Line N is parallel to line L. The third way to denote parallel lines is in the diagram itself. For example, if I would color in the arrows, that would represent that these two lines are parallel inside the diagram. If I had another set of parallel lines, let's call them K, lowercase k, and H, I would denote these two parallel lines with two arrows. Therefore, the lines that have single arrows would be parallel to single arrows, and the lines that have double arrows would be parallel to lines that have double arrows. I also could write this as K is parallel to H. Another set of lines is called skew lines, lines that do not intersect and are not in the same plane. Here, line M could be considered in the white surface of this plane. Line N actually could be coming out of the plane towards you like an arrow. Therefore, they do not intersect, and they are also not in the same plane. Lines can be parallel. Therefore, we also have a definition for parallel planes. Two planes that do not intersect are parallel planes. A line and a plane that do not intersect are also called parallel. Let's answer some questions based on the previous slides. First, name a plane parallel to plane AGC. AGC, B is the left side of the cube. Therefore, a plane parallel to that would be the right side of the cube, which would be plane HDE or HDEF. Next, name all lines parallel to line GE. That means we need all lines that do not intersect with GE, but they must be in the same plane as GE. Here, line CD is parallel and also is in the same plane. So that would be one of our solutions. Also, line AF is in the same plane and does not intersect. That would be a solution. Line BH, we could draw in the plane that would contain both of them, and BH does not intersect with GE. Therefore, that would be a solution. Line AB and line FH do not intersect with line GE, but they are not in the same plane. They are skew lines to GE. Therefore, those are not solutions. Name all lines skew to line DE. Therefore, we need lines that don't intersect with DE, but also that are not contained in the same plane as DE. Here is line DE. FH does not intersect, but is in the same plane. Therefore, they are parallel. AB does not intersect, but they are in the same plane. Therefore, they are parallel. And CG does not intersect, but are in the same plane. Therefore, they are parallel. The lines that do not intersect, but are in different planes would be line BH and line AF. Line AG and BC also do not intersect with DE, and they are also not in the same plane as DE. Therefore, AG and BC are skew to DE. Name the intersection of plane AGF, which is the back side of the cube, and BGC, which is the left side of the cube. Recall that when two planes intersect, their intersection is a line. Therefore, the back part of the cube and the left side of the cube intersect at line AG. Let's answer some questions referring to a different diagram. Name the planes that intersect at line GE. Two planes intersect, they intersect at a line. Here, the two planes are AEG and DEG. The easiest thing to remember is that when you generate the two planes, that they have the two letters that are also in the line. Are plane BCJ and plane EDH parallel? In the diagram, BCJ, which is BCIJ, and EDH, which is EDHG, appear to be parallel. But recall, planes are continuous in all directions. Therefore, if we would continue both of these planes below the diagram, at some point they would intersect. Therefore, are the planes parallel? The answer is no. Name two lines skewed to line BC. Therefore, any line skewed to BC would not be intersecting with line BC and would not be coplanar or in the same plane as line BC. Two lines that I have as identified as solutions for this problem are line DH. DH is not in the same plane as BC, and it does not intersect BC. Line AF. It is not in the same plane as line BC, and it does not intersect with line BC. There are other solutions inside the diagram. Name a pair of parallel planes. The only two planes in the diagram that would be parallel are A, B, C, D, E, and the back of the diagram, which would be F, J, I, H, G. Planes A, B, C, and F, J, I. All other planes are shown to be intersecting at a line inside the diagram, or if you extend the planes, will intersect at some point outside of the diagram.